About 65.5 million years ago, at the end of the Cretaceous period, there was a mass extinction that put an end to the age of dinosaurs. This mass extinction marks the end of the Mesozoic era and the beginning of the Cenozoic era. The event is also known as the KPG or KT extinction. I'm the host, Faye Melton, and this is what happened in the End Cretaceous Extinction. Towards the end of the Cretaceous period, an asteroid that was 10 kilometers in diameter hit the Earth at the Yucatan Peninsula and the Gulf of Mexico. But how do we know this was an asteroid? In the 1970s, a geologist named Walter Alvarez was studying the stratigraphy at a site in Italy and noticed the clay layer where the microfossils were almost entirely gone. This was a big sign that an extinction event occurred when this layer was forming. The layer marks the end of the Cretaceous period and is known as the KT boundary. The KT boundary ended up being studied by scientists around the world. After further research, they found that the layer contained about 30 times more iridium than the surrounding layers. Iridium is an element found in meteors. This was one of the first signs that a massive impact could have caused the mass extinction. Using the amount of iridium that geologists found, they were able to calculate the size of the asteroid, 10 kilometers in diameter, and use that to estimate the effects that an asteroid that size would have had on Earth. There were also other pieces of evidence found in the clay layer, like spherules and shocked quartz. Spherules are small pieces of natural glass that form from melted rock when an asteroid or meteor hits Earth. Shocked quartz can also form in these events when the intense pressure from the impact causes fracturing and creates really fascinating blind patterns. These findings were just some of the ways in which we determined that an asteroid must have hit Earth at this time. So we can see the KT boundary, but what about the crater? An impact this size would have created a massive crater, and it seems that it would be easy to find, but for a while we couldn't find it. Then when geologist Glenn Penfield was measuring gravitational fields in Mexico, he happened to discover the crater buried in the Yucatan Peninsula. An asteroid this large would have huge impacts on the climate and species across the globe. The quickest deaths would be those of the organisms who were directly hit by the asteroid or within enough distance to be killed by the pressure and heat coming from the impact. The impact also would have sent an enormous amount of dust from the asteroid and the Earth's surface into the air where it would quickly spread. This could prevent the sun's energy from reaching the Earth's surface for months, resulting in what is called an impact winter. The sun and temperatures are really important for life on Earth, and an issue like this would have drastically impacted the process of photosynthesis, which most plants need to survive. Another interesting way in which the asteroid could have affected the planet is by hitting rocks containing elements that would be released into the atmosphere or would react with the impact. For example, researchers found sulfur in the rocks at the site of the massive impact, which can change the climate across the globe by affecting temperature or creating acid rain. There's another series of events that are debated to have played a part in the KPG extinction. From 67 to 63 million years ago, there were flood basalt eruptions occurring in India, forming what is now called the Deccan Traps. As a reminder, the End Cretaceous extinction occurred about 65.5 million years ago. Flood basalt eruptions are when mafic lava comes up primarily out of fissures rather than volcanic mountains. An eruption may have lasted over 100,000 years, and eruptions continuously occurred in the same area over the course of a few million years. We know when these eruptions occurred and their approximate size by observing the basalt left in India and dating ash within the basalt by using its radioactive elements. So how would flood basalt eruptions affect the climate and species of the Cretaceous period? Well, when the flood basalt eruptions took place, they released gases like CO2 and sulfur-rich gases into the atmosphere. An increase in greenhouse gases like CO2 caused an increase in average global temperature over time. Major changes in temperature can be devastating for certain species who are unable to adapt to these changes. Sulfur-rich gases eventually lead to the production of sulfuric acid, which is released as acid rain. This acid increases ocean acidification and harms a variety of marine species as the acid dissolves their calcium carbonate shells. So as you can see, the combination of massive impact and flood basalt eruptions near the end of the Cretaceous period was devastating for a large portion of land and marine species. According to National Geographic, 76% of total species on Earth were wiped out in the KPG extinction. Some of those who went extinct include certain species of plankton, ammonite, pterosaurs, mosasaurs, and all non-avian dinosaurs. Small mammals were some of those who were able to survive and move on to the Cenozoic era. This may have been due to their ability to burrow or their body size. And while this event is known as the end of the age of dinosaurs, it's important to note that some of the survivors included avian dinosaurs who evolved into the diverse birds we see in the present day.